Welcome. In this video we're going to look at how to calculate the present value of a unequal cash flow. So that's what we have here. We have a problem that says you make an investment in a new machine with the following cash flows, and you get these cash flows the next 4 years, and using a discount rate of 9% calculate the present value. So we're going to do this both in Excel and using the formulas because Excel's too easy, and I want you also to understand the formulas. So let's do Excel first. Let's open a function box, and we want to find net present value, which is a shortcut. So let's open this up, and we'll put in our rate, which is 9%. And then for our values, all we have to do is drag and drop these into where it says value 1, and it calculates the net present value of these 4 cash flows. And you can see here's the result, $92,036.23, and it puts it in the cell. That's too easy, and I want you to understand what Excel is doing to get this amount. So let's do this by starting out drawing a timeline. So let me get my pen here. Oops, I didn't want to draw a line there. Let's start right here. Okay, so we're starting at time 0, which is today, and then we've got 4 periods. We have end of year 1, end of year 2, end of year 3, and over here we have end of year 4. And we can put all of our cash flows on the timeline. So let's start out with our $12,000. Then we have our $23,000, our $45,000 in year 3, and $38,000 the last year, or year 4. And our interest rate, we said, was what? This 9%. So let's put this on the timeline so we don't forget about it. And then what we want to do is we want to calculate for each one of these the present value, what they're worth in today's dollars. So that's what we're going to do here. Okay, so if you recall, our present value formula goes like this. PV equals the future value times 1 divided by 1 plus the interest rate to the nth power for each year. And we also said you could rewrite this formula as PV equals FV times 1 plus R to the minus N. And the reason why I like this formula better, because you can use this in Excel and you don't have to put all this in. This is just a little shorter formula to put in Excel, and it works exactly the same way. So let's demonstrate how it does work, and we're going to take our numbers and throw them in the formula. So if you recall, we have to set our future value equal to 1, and then we multiply that times 1 divided by, in this case we have 1 plus our 9% interest rate, and for the end of year 1 we put in the first power. So if we do that, we get a factor of 1, let's see, with me a second. I hope you're working along on this with your calculator. I hope you're working with me on this. So let's see, we're at the end of year 1. Our interest rate is 9%. And so we're going to get a factor here of 0.91743. That's for year 1. So now we do the same thing for year 2. Take our formula. We still have 1 plus 09. And the only thing here that changes is the power, because we're at the end of the second year. So if I put that in my calculator, you can do this along with me. We should get a rate, or a present value interest factor, which comes out to 84168. Okay, so let's do year 3. Same formula, nothing changes except for we raise this to the 3rd power. And that should give us a factor over here that's equal to 0.77218. And we have one more for the 4th year. We raise it to the 4th power, and let's see what we get on our calculator. Do it along with me. We get 0.70843. 0.70843. Okay, so if we multiply each one of these factors times each year, over here for 12,000, we've got to take our $12,000 and multiply that times 0.91743. You should come out with over here 11,009.16. Okay, let's do the next one, which is 0.84168 times $23,000. That's the amount we received at the end of year 2. That should give us over here 19,358.64. 19,358.64. And let's do the next one, which is 0.77218 times $45,000. That's going to give us $34,748 and 10 cents. Okay, and we'll do the last one, which is 0.70843 times 38,000, which is going to give us down here 26,920.34. 26,920.34 cents. And now if we add these all up, let's see what we get. And you can add along, or you can just wait till I'm finished if you want. 92,036.24. And that's pretty much the same answer that we got using the Excel net present value formula. This is what I just added. 92,036.24. And you want to compare that with this number here that we did using Excel. Another way you can do this is to add these numbers up and get our, what happens is if you do that, you're going to get a present value interest factor of an annuity. Well, you cannot do that because each of these numbers are different, so that would not work. If they were the same, you could do that, so let's forget about that. But I just wanted to show you how you could do this with the formula, and that's what we did, so we're done. We'll see you in the next slide.